Hey everyone, today we're going to learn our third method, for solving linear systems. So if you remember back, we started off by graphing, then we learned substitution, and today we're learning elimination. So when we're talking about elimination, I think about when I'm eliminating, I'm getting rid of something. And that's really the idea in the elimination method is we're trying to get rid of one of the variables so that we can solve for a variable. So here's how this method is going to work. The first thing we're going to do is we're going to make sure that all of the terms are lined up vertically. Remember, vertically we're thinking up and down. So what this really means is that x should be on top of x and y should be on top of y. So for example, if we look in our equation here, we can see our x terms, one's on top of the other, our y terms, one is on top of the other. And that's what we mean by being lined up. So x's are on top of x's, y's are on top of y's. So in this problem, that's been done for us, but that won't always be the case. The next thing we're going to do is examine the coefficients. Now remember, I'm going to make a note here. The coefficients are just the numbers in front of the variables. I'm sorry, I know I'm kind of squished in there. So the coefficients are the numbers in front of the variables. So we're going to examine the coefficients, and we want two of the coefficients to, I'm going to say, to be opposites. Because that's how we're going to eliminate one of those variables. So we want two of the coefficients to be opposites. So really what we want here is for one variable, the coefficients should be opposites, and we'll get to how we do that. The next thing we're going to do is we're going to add the two equations together. And so what we're going to do is we're going to add vertically, and we're always going to use addition. So then we're going to solve for one variable, right? We've eliminated a variable at this point, so there's only one left. And then just like in substitution, we're going to use the value from step 4 to solve for the other variable. All right, so let's see how we're going to make this happen. So I'm just going to rewrite this to give myself a little more room. So x plus 2y equals 12. Then I have negative 3x plus 2y is equal to negative 12. So in step 1, we already talked about my x's are on top of my x's and my y's are on top of my y's. So far, so good. Now, we need to look at the coefficients. We want two of them to be opposites, right? So it means the same number, and maybe I should add this, same number, but a different sign. Okay, so in this case, here my coefficient, even though I don't really see it, is a 1, and this one's a negative 3. So those aren't opposites. Here, if I look at my coefficients of y, one is positive 2 and the other is positive 2. So they're the same number, but they're not a different sign. So here's what we're going to do. If this is a positive 2, what I want is for this one to be a negative 2. So what I'm going to do is I'm going to take the left side and multiply it by negative 1. And I'm going to take the right side of my equation and multiply by a negative 1. And here's why I do that. My first equation stays the same, x plus 2y equals 12. But now if I distribute the negative 1, I get negative 1 times a negative 3 is a positive 3x. A negative 1 times a positive 2 is a negative 2y. And on this side, I have a negative times a negative gives me a positive 12. What that allowed me to do now for my y terms, my coefficients are opposites. One is a positive 2 and one's a negative 2. And that's going to help me eliminate a variable. So here's how that works. Step 3 said to add the two equations, and we said we were going to add vertically. So here's what I mean by that. This was a 1, we knew. So if I take 1x, I'm going to add 3x. 1 plus 3 gives me 4x. Now here I have 2 plus a negative 2. Well, we know adding a negative is subtracting. So if I do 2y minus 2y, that term is just going to cancel. And now I'm going to add 12 plus 12 gives me 24. And so here we've eliminated the y. We got rid of that y value. So now I'm going to solve for x by dividing by 4. And I get x is equal to 6. So now, just like before, I know what x is. So I'm going to take my first equation, x plus 2y equals 12. I know that x is 6, so I'm going to replace x with 6. So 6 plus 2y is equal to 12, and now we're going to solve for y. So I'm going to subtract 6 on both sides. That's going to cancel. I get 2y is equal to 6, and if I divide by 2, I get y is equal to 3. So my solution, I think, is 6, 3. Now, you know me, I'm always going to check my answer, and I'm going to put that up here because I'm running out of room here. So check. So my first equation is x plus 2y equals 12. My x I know is 6 plus 2 times the y is 3, and I'm hoping that's 12. If I put this in my calculator, I'm going to get 12 equals 12. So far, so good. Sorry guys, they're testing the alarms here if you hear any weird noises. My next one is negative 3x plus 2y equals negative 12. So negative 3 times my x was a positive 6 plus 2 times my y coordinate is 3 equals negative 12. So again, I'm going to put this all in my calculator. So I've got negative 18 plus 6, negative 12 is equal to negative 12, and then I know my solution is correct. Let's see. Let's do number 1, and then that'll be it for today. I think that'll be plenty, and that'll give us some good stuff to discuss when we're all back together. All right, so for number 1, step 1 said to make sure your variables are lined up vertically. Remember that meant x is on top of x and y is on top of y's. So if I look here, we're in good shape. X is over x, y is over y. So step 1 has been done for us. 2 said to examine our coefficients, and we want, for one of the variables, we want those coefficients to be opposites. So if I look at x, we actually got pretty lucky here. My coefficient of x is positive 2 here and negative 2 here. So actually step 2 has been done for us as well. We don't need to force those to be opposites. So now we're all the way down to step 3. We're going to add these together. So again, my 2x and my minus 2x, those are going to cancel out. Now I'm adding here. I have 3y plus 5y is going to give me 8y. 11 plus 13 is going to give me 24. So then I'm going to divide by 8 on both sides, and y is equal to 3. So now I have to go back and figure out what x is. So I'm going to take my first equation, 2x plus 3 times, well, y we just found out was 3. That came from here. And that's going to be equal to 11. So 3 times 3 is 9, so I have 2x plus 9 is equal to 11. I'm going to subtract 9 from both sides. 2x is equal to 2, and if I divide by 2, x is equal to 1. So now we just have to be careful about our ordered pair here. We know ordered pairs are x comma y. My x was 1, so that has to go first, and then 3. Now I'm going to do a check. So for my first equation, I have 2 times the x-coordinate is 1, plus 3 times my y-coordinate is 3, and that hopefully is equal to 11. So I have 2 plus 9, I get 11 equals 11. And then I've got negative 2 times my x-coordinate, which is 1, plus 5 times my y-coordinate, which is 3, and that should be equal to 13. So again, I can use my calculator, but I get negative 2 plus 15. That's going to give me 13 equals 13. And again, I know my solution is correct. So those are the basics of elimination. And again, now we'll have a couple problems that we can start class with to make sure everyone's comfortable with this method. All right, see you tomorrow.